Well, we are here once again. Remember, in programming, what we are simply doing is we are converting what we know into a computer program so that the program can be able to help us. Today we have a problem that we need to solve, and the problem here is to determine the BMI of a patient, and we are required to do a three-step process. One is to design our algorithm, and thereafter we are also supposed to draw a flowchart and then now write a program. So the very first part of it is this one here, where we are doing the designing of our algorithm, and the algorithm has got these three steps. The first step is to capture the weight and the height, because these are the key variables or elements that we need to use for us to determine the weight vis-a-vis the height to get the BMI. Then once we have captured the weight and the height of a patient, or anyone who has just visited, someone could just visit to, they want to just know the BMI, so we compute that BMI. How do you compute it? It is given by the formula weight in kilograms divided by the height in meters, and that height you squared, height squared in meters. I think that is a better version. Once you have computed your BMI, then you have to print the BMI, right? You have to print the BMI, and that is how you design your what? Your algorithm. That bit, remember, the algorithm is standard. There's no standard way of writing an algorithm, but rather you have to just show the logical sequence of steps. Someone could come with 5 steps here. That is fine, as long as they give us a solution that we are looking forward to get. So we need to translate this into a flowchart, and remember, a flowchart is simply a diagrammatic representation of our algorithm. So you have your algorithm on one hand. When you convert that text into a diagram, it becomes what? A flowchart. And here is already a pre-prepared flowchart. This is oval, marking the start and the ending of our what? Of our flowchart. So this is the stop and this is the start. Then we have a parallelogram which we use it to capture the input and also display the output. And as you can see, after starting, we have now enter weight and height. Here it is. You have the weight and you have the height, because these are the variables that you are using to compute your BMI. So the next one is a rectangle, and the rectangle is used to store processes. The process is simply, I would say, it is a transformation of maybe data into something. That is a process. And when I say something, I simply mean data into information. We want to make a decision based on that information. So here you have compute your BMI, weight versus or divide by height squared in meters. Now once you do that computation, then you print, and I would show this in a program how we are going to do it. Probably we can treat our start as you're launching the environment, and then now you are now telling the user to enter their weight and their height, and then the program is able to compute the BMI and then display it to the user, and then you stop. And that is what we will be able to see in the phases of our program. So let's write the program now, and this is what we are going to do. We have, this is an empty file that is clean. So we want to allow the user to enter some values here. So we have to define our variables. Remember, before you use a variable, you have to define it, and then you have to maintain that name all along in your program. So let's define our variables. I'm looking at weight. Weight can be something like 90.3. That is no longer an integer. That is now what we are referring as a float, or a double. Again, your height could be, let's say you are 159 centimeters. You convert that into meters, it will be 1.59. So that again cannot be an integer, rather it will be a float. So let's say float. Let's float these things. Are they float? That is a data type. And then we cannot just say weight. Let's use what we know, because if you use x, y, z, we might be confused what is x and what is y. And then we have the height like this. And then we can say BMI like that. So we have floated three variables here. The first two variables, that is the weight and the height, will be entered by the user. So let's now ask the user to, let's put something on the screen for the user to read and then act according to the instructions. So let's tell them, enter your weight in kgs. I think kgs would be more understood in kgs rather than if I write kilograms. So with that /t, it means we are doing a tab, a space horizontally. Okay, then printf, then we're gonna have a scanf quickly, and this is, we are gonna tell this person now to, we are now allowing them to enter data through the keyboard. So %f for float, and then we ampersand or weight. So we want to enter the weight, so we are going to point that variable to weight. Yes, okay. Then we say print f again, and then we tell this person to enter your height in meters. So let this side write like that, meters, then /t, and then we terminate that statement using a semicolon. You can actually make errors where you are typing. Probably you did not refer to a variable very well. Probably you did not terminate the statements in the nice way as they are required. You then do what you call debugging, because a bug is an error. Bug, B-U-G, that is an error in a code, and you should endeavor to make your code error free. That is what we refer as debugging. You can see from here, there is debug, means you remove the error. So let's scanf, and then we are saying %f again, and then we are now calling the height, and you call it using ampersand, you point it, you are referring to it, height, and then we're gonna say printf. No, before we printf, let's do the logics. So we have said our BMI is the same as weight. Yes, you're gonna type it the way you typed it the first time. Weight, divide that by, then we can just have a bracket, so that once we have done height times, when we say squared, that is number times that number. So height times height. Is this the same as this? I hope so. And then we will terminate. So we want to return this by saying printf, your BMI is, then we're gonna do this %, yes, %f, like that, like this. And we want this to start on a new line, so probably we would want to use, let's introduce this one here, rather than to start on a new line. Ideally, leave at this one, even if we did not write it, it would start on a new line. But let's see what happens if we run this program now. Let's build, and then we run. Yes, there's an error, and that is what I told you, that anytime you write a program, you be sure that there will be errors, and so you have to debug those errors. So what is the error here? Look at this error, weight undeclared. So there is we have used a variable here that is not declared. So look at this and look at this. There is swapping of I and E in this word. So, and the right, actually we don't care the spelling here. The most important thing is that what you define up here is what you use down here. So we defined it using EI. So let's do that. Yes. Okay, now let's try to run it again. So let's enter. This guy has got 100 kgs and his height is 178. So that is 1.78. And your BMI is as indicated. It is giving us 00, which is not true. That should give us some value. So let's check what could be the problem. All right, the issue here is we've not called this the value of that BMI now, so we need to do that. That is an error which we call it a runtime error. The program seems to run, there's no error, but everything, it doesn't give you the value as you had anticipated. So this guy has got 100 kgs again, and this is 1.78. And there you see, you have a BMI of 31.561674. So that is how you compute this BMI thing, okay, using a program. But you probably want to change that format of numbering. Maybe you only want to have 2 decimal points. Then you will have to include it here and say 0.2F. Let's see if that's going to work for us. And then we say again, you have let's say this guy has got 80 and is 1.75. Okay, you see, yes, this is what I was referring to. We now have 2 decimal points. And how did we define that? By including this dot 0.2. That is to tell the program that we only want it to do decimal points. It would be able to do all those other things that it is actually supposed to do. Great. And that is how you compute the BMI. And next time we are going to make a decision based on our BMI, probably in the next subsequent bulletin, we will be able to do that. So keep following as you enjoy this tutorial. Well, I just thought of something. Instead of writing this, instead of writing our first program looked like this, okay, and this was working perfectly. Instead of having to write this times that, we can actually introduce another library called math. Math. So it's we just include, we are going to call this function and we say math. C is rich, it has got so many other functions. So we include math.header. It is going to call mathematical formulas that are there. And in this case, instead of writing this here, I would simply introduce what we call power. And pow is a non-function. That is a library function. We don't have to define it. And what we are powering here, we are doing height like that. Then we just supply 2. When we supply this 2, it means we are going to raise this height by 2. That is now height squared. When we run this program, expect that it's going to perform. Okay, let's again to our 100 guy, and then we do our, this guy is 1.78, and you see perfectly it's working. Your BMI is that. So you can, instead of writing height times height, you can change power and then use height square. If I change this to 3, it's going to raise the value by 3, this one here. If I change it to 5, it's going to use it as power 5. But for now, if you know you are not capable, then refer to the earlier version. I mean, just pull the play backwards and then use that to do your work. Otherwise, it was a pleasure having you in this tutorial. I wish you nice moments as you get to understand how to run about C programming. Have a good time.